Welcome to A-Level and AP Physics. In today's lesson, we will discuss an important past paper question on nuclear physics from March 2021, paper 4, variant 2. In this question, we will discuss what is meant by spontaneous and random nature of decay, how to calculate decay constant, and some other questions about nuclear physics. For part A, we need to state what is meant by spontaneous decay and what is meant by random decay. And this question has 2 marks. First of all, we will only focus on what is meant by spontaneous decay. Spontaneous decay simply means that the radioactive decay does not depend on external factors such as temperature and pressure. For example, if we have nucleus, let's say this is one radioactive nucleus. By changing temperature or by changing pressure or other factors, we cannot increase the rate of decay or we cannot decrease the rate of decay because it is independent of external factors. When the time will come, it will just simply decay. So its decay is independent of external factors. So that's the reason radioactive decay is spontaneous in nature. Simply you can mention radioactive decay is independent of external factors such as temperature, pressure, and also neighboring nuclei. So let's say we have another nucleus here, another nucleus here. So decay of this nucleus, let's say we focus on this one. The decay of this nucleus does not depend on temperature, does not depend on pressure, and also it does not depend on these neighboring nuclei where it is located. So it also does not depend on that. So that's the reason we call radioactive decay is spontaneous in nature. It doesn't care about external factors, simply we can say. Now let's move on to next one. What is meant by random decay? So that random decay simply means that if we focus on this nucleus, for example, in this sample, we just focus on this nucleus. Random decay simply means that we cannot predict when this nucleus will decay, and also we cannot predict which nucleus will decay. So that is meant by random decay. First of all, let's try to understand what is random decay. So with the help of this animation, so you can see, if I look at this one, you can see half of these nuclei, means after one half-life, half of these nuclei decay, but you cannot say which nucleus will decay next. So this is telling you this is random decay. And also we cannot tell the time when one particular nucleus will decay. So let's look at next one, means after next half-life, half of nuclei will decay, but we cannot say which nucleus will decay. So this is after next half-life, and this is again after next half-life. Half of them decay, but we cannot say which nucleus will decay and when any particular nucleus will decay. So this is what is meant by random decay. I hope it is clear to you now. And the probability of decay of any nucleus per unit time is the same. For example, the probability of dying means how many people die on this planet. There is a certain probability, and that probability is the same for every person on this planet. So that is also true for these radioactive nuclei. Now let me explain to you how you can write down the answer. So this is how you can write down the answer. So this is a kind of proper answer. If you mention these points, you will get full mark. So it is not possible to predict when an individual nucleus, means if you focus on this nucleus, you cannot say when this one will decay. And every nuclei has constant probability of decay per unit time interval. So they have the constant probability of decay per unit time, that what we call is the lambda, constant probability of decay per unit time. So this is called decay constant, lambda. Lambda is the same for every nuclei. So this is decay constant. So this is how you need to write down your answer. For part B, activity of a sample is given, and activity of the sample is 5.2 megabecquerel, and the mass of the sample is also given. So first of all, let's write down what is mass of the sample. Mass of the sample is 1.0 times 10 to negative 9 kgs. And activity of the sample is also given. So simply we can say A is given. This is equal to 5.2 mega BQ. So simply we can say this is 5.2 times 10 to 6 BQ. BQ is unit of activity becquerel, and 1 becquerel is equal to 1 decay per second. Now we also need to understand what is the mass of this nucleus. So the mass of nucleus we can say is small m. Mass of nucleus is 90 U. So the mass of nucleus is equal to 90 U because the mass number of this one is 90. Now we have to convert this one into kgs. So we have to multiply with 1.66 times 10 to negative 27 kgs because 1 U is equal to 1.66 times 10 to negative 27 kg, and this is given in data. You can find the value of U on second page of this paper. Now question is asking us to calculate decay constant, means we need to calculate lambda. In order to calculate lambda, we need to find the value of A, and also we need the number of nuclei n, but A already we have. Now we need to find out n. So how we can find out n? So this is difficult part in this question. In order to find the number of nuclei, the total mass of the sample we have, so simply we can divide the total mass of the sample by the mass of one nucleus. So the total mass of the sample in this case is 1.0 times 10 to negative 9 kgs divided by mass of one nucleus. And mass of one nucleus is 90 U, 90 AMU you can also say. So here we have to write down mass of one nucleus. Now if we solve this one, we do this calculation, our final answer will be 6.69 times 10 to 15. So this is the number of nuclei we have in this sample, and we need to calculate lambda. So simply we can divide activity of this sample is given, that is 5.2 times 10 to 6. Now if we divide this one by number of nuclei, we can find out lambda, means decay constant we can find out. So simply we have to divide by number of nuclei, and our final answer in this case will be 7.77 times 10 to negative 10 per second, means this is per second. The unit of decay constant is per second. So we can write down our answer up to 2SF. Simply we can say this is 7.8 times 10 to negative 10 per second. So this is our final answer. For second part, it is given to us the activity of the sample after a time of 1 half-life is found to be greater than the expected 2.6 mega BQ. Suggest a possible reason for this, and this question has only 1 mark. First of all, let's try to understand what question is telling us. In the question, it is given to us that the initial activity of the sample was 5.2 mega BQ. So this is mega BQ, and after 1 half-life it has to decrease to half, means the activity should be 2.6 mega BQ. So simply we can say after 1 half-life, this is what we are expecting. After 1 half-life, activity should be half, but according to our observation, the observed activity, so we can say observed, so this is we can say observed activity, this is greater than expected. So simply we can say it is greater than expected. Question is asking us to explain why it's like this. Observed activity, this is greater than expected. There can be 2 reasons. The first reason can be the daughter products are radioactive. So one reason can be daughter products are radioactive, or we can say daughter products are unstable. So this can be one reason. And the second reason can be due to background radiation. The second reason can be background radiation. So that's the reason the observed activity is greater than expected one. So these are 2 possible reasons. So you can write any one of them and you will get 1 mark. I hope it is clear. So let me show you how to write down the answer. This is how you can write down answer. So there are 2 points. You can mention one of them. You can say the daughter products of nucleus are unstable, or you can say it's due to background radiations.